Why are you willing to pay $100 to eat a slimy land snail in a French restaurant, but would throw up if a crispy, deep-fried cricket touched your plate? To the Western mind, snail escargot is high-class gastronomy. An insect, however, is a biological hazard. But here is the paradox. Scientifically, insects are far cleaner, packed with more protein, and require virtually zero resources to harvest compared to any animal we eat today. Yet to one half of the world, they are a delicacy. To the other, they are a living nightmare. This deep cultural divide isn't an accident of taste. It is a defense mechanism written directly into Western history, geography, and as modern science has just revealed, the very DNA of the European population. For the vast majority of human history, eating insects was not a choice. It was survival. Our common ancestors ate them daily. But if we look closer at Western history, we find a shocking truth. Europe did not always hate insects. In ancient Greece, the philosopher Aristotle, one of the founding fathers of Western thought, wrote in his History of Animals that cicadas were a highly prized treat. He noted that they tasted best in their nymph stage, just before their final molt, when their bodies were plump and soft. Centuries later in Rome, the naturalist Pliny the Elder recorded in his Natural History that wealthy Roman aristocrats considered a large wood-boring beetle larva, which he called causus, to be the pinnacle of luxury. Roman elites did not just forage for these grubs. They actively farmed them, fattening them on wheat flour to make them larger, juicier, and sweeter before throwing them into hot pans. So what happened? How did a continent that once served beetles at aristocratic Roman banquets transform into a society where finding a fly in a soup ruins a meal? Why did entomophagy completely vanish from the Western culinary landscape while thriving in the East? The first part of the answer begins with a simple mathematical law of nature: optimal foraging theory. In ecology, this rule dictates that no organism can survive if it spends more energy hunting or gathering food than the food itself provides. When early humans migrated out of the warm tropics and pushed into the freezing, temperate forests of northern and western Europe, the energy economics of food shifted overnight. In Europe, the climate is defined by cold, harsh winters and short growing seasons. Insects in these temperate zones are tiny, seasonal, and vanish completely during the winter months. Imagine a hunter-gatherer in the ancient black forests of Germany. Trudging through deep snow, turning over frozen logs, and peeling back tree bark just to gather a handful of frozen ants or beetle grubs is a catastrophic waste of energy. The calories burned during the hunt vastly exceed the energy gained from the catch. It was a mathematical path to starvation, but Europe's cold, vast grasslands offered an alternative that the tropics did not. Massive, warm-blooded mammals. Sending a single red deer or domesticating a cow yielded an enormous, highly concentrated package of protein, fat, and calories that could sustain a family or an entire tribe for weeks. When you have access to 1,000 pounds of beef, venison, or nutrient-dense dairy products, and cheese, spending time gathering insects becomes a waste of human labor. In tropical Asia and Africa, however, the ecological math was completely inverted. The warm, humid climate meant that insects grew to massive sizes, reproduced rapidly, and swarmed in giant, predictable numbers. A harvester in Thailand or Cambodia could sweep a net through a rice field once and gather pounds of highly nutritious grasshoppers in minutes. In the East, insects were a low-cost, high-yield, and year-round source of protein. Geography drew the global food map long before culture ever did. However, the real wall keeping insects off Western plates isn't just outside in the environment. It is inside the European stomach. Recently, a major genomic study published in the journal Science Advances, led by geneticist Corentin Librado, analyzed ancient human DNA dating back 9,000 years. The researchers made a startling discovery that bridges the gap between culture and biology. To digest an insect, the human body must deal with chitin. Chitin is the tough, fibrous polymer that forms the hard outer exoskeleton of insects, essentially their natural armor. Humans cannot absorb raw chitin. It must be broken down. In the human digestive tract, this task falls on a specific enzyme called acidic chitinase, which is expressed in the stomach. This enzyme is encoded by two main genes, CHIA and CTBS. The genomic analysis of ancient remains showed that our prehistoric ancestors, including Neanderthals and Denisovans, possessed highly active and functional variants of the CHIA gene. They could digest insect shells with ease. However, as the agricultural revolution swept through Europe 9,000 years ago, a massive genetic shift occurred. With the rise of pastoralism, dairy farming, and grain cultivation, Europeans established a steady, abundant supply of domesticated meats, milk, wheat, and barley. Because the European diet shifted entirely away from wild foraging to agricultural crops and livestock, the human body adapted to its new environment. It followed the biological rule of use it or lose it. Producing the acidic chitinase enzyme requires cellular energy. If the body doesn't need to digest insect shells anymore, continuing to produce the enzyme is a waste of biological resources. Over thousands of years, loss-of-function mutations accumulated in the CHIA and CTBS genes of European populations. The genetic instructions to build the keys that unlock chitin were slowly corrupted and deactivated. Consequently, when a modern Westerner attempts to eat a whole insect, their stomach physically struggles to break down the exoskeleton. Without sufficient chitinase, the tough shell passes through the stomach largely intact, causing indigestion, stomach cramps, and bloating. In addition, the sharp, indigestible fragments of the shell create a highly unpleasant, scratchy sensation in the throat. Over generations, this physical discomfort was translated by the human brain into a powerful psychological reflex: disgust. Disgust is an evolutionary defense mechanism designed to prevent us from eating things that make us sick or that our bodies cannot process. The brain labeled insects as dirty, toxic, and inedible to protect a stomach that had lost its ancient tools. What began as a genetic adaptation to save energy under a new agricultural diet became a rigid, subconscious cultural taboo. This biological aversion was further magnified by the way Western agriculture developed. In a pastoral and farming society, insects ceased to be a neutral part of nature. They became the ultimate enemy. A single swarm of migratory locusts could descend upon a wheat field and wipe out an entire year's harvest in a matter of hours, plunging a medieval village into a winter of starvation. Insects were no longer food. They were the thieves of food. They were synonymous with famine, ruin, and death. As cities grew and density increased, the association between insects and disease grew even stronger. The rise of early medicine and public health identified pests like fleas, lice, and flies as the primary vectors for devastating plagues, including the Black Death, which wiped out up to 60% of Europe's population in the 14th century. The Western subconscious permanently linked insects to filth, contamination, and death. The disgust was no longer just an individual reaction, it was institutionalized. To eat an insect was to invite the plague. Yet, history has a way of turning our deepest taboos upside down. Today, humanity is facing an unprecedented ecological crisis. The global population is skyrocketing, and our current method of producing protein is unsustainable. Industrial livestock farming is a primary driver of climate change, deforestation, and water depletion. To produce just 1 single kilogram of beef, industrial agriculture requires 15,000 liters of water, massive amounts of grain feed, and releases vast quantities of methane gas into the atmosphere. The planet simply does not have enough land or water to support a Western-style beef diet for 8 billion people. Once again, the scientific community has turned its attention to insects. Nutritionally, insects are a miracle food. Crickets and mealworms contain protein levels that rival beef, but they require 2,000 times less water, 12 times less feed, and produce a fraction of the greenhouse gases. They can be raised vertically in small spaces, utilizing organic waste as feed. In recognition of these facts, the European Union has recently made historic legal moves. The European Food Safety Authority has officially approved house crickets, yellow mealworms, lesser mealworms, and migratory locusts as safe for human consumption. Major supermarket chains in Germany, France, and the Netherlands have started stocking products like protein bars, burger patties, and pastas made with insect ingredients. Legally and scientifically, the path has been cleared, but this is where the modern food revolution is hitting a brick wall. A legal decree from Brussels cannot easily erase 9,000 years of genetic programming and cultural conditioning. When surveys are conducted, the vast majority of Western consumers state that they would rather starve than eat whole insects. The psychological barrier of disgust remains completely unbroken. To bypass this biological wall, Western food tech companies are relying on a strategy of visual camouflage. They are not asking consumers to bite into a whole, crunchy cricket. Instead, they are grinding the insects into a fine, defatted powder, often marketed under scientific-sounding names like Asheta protein. By stripping the insect of its legs, eyes, and antennae, and turning it into a neutral, beige flour, they can blend it undetected into familiar comfort foods like pizza dough, cookies, and protein shakes. They understand that to get a Westerner to digest an insect, they must first fool their eyes and their brain. The Western rejection of insect eating is not a sign of civilizational advancement or culinary superiority, as colonial explorers once proudly believed. It is simply an evolutionary scar, a relic of physical survival in a cold, temperate past where the math of energy favored the mammoth over the beetle. As the climate crisis forces us to confront the limits of our planet, the clash between environmental reason and biological disgust will shape the future of human nutrition. The ultimate question is no longer whether bugs are the future of protein. The question is whether the Western mind can use technology and willpower to override its own DNA and swallow the very creatures it spent 9,000 years trying to forget.